Okay, so again, 1.4 part one is solving linear equations. This should be relatively easy, except for the fact that we do throw in fractions in here. And you guys are probably a little rusty with the fractions part. All right, so we're solving. What does that mean? Remember our terminology? Finding x, right? Isolating the variable. In other words, we want to get x by itself, right? X equals something, a number, or it could be an expression. So part A, we have 4x plus 7 equal 27. Now, if I still, but I do have students in Algebra 2 juniors, even seniors, that still get their like terms mixed up here. Um, like if they want a minus 7, they'll minus 7 out of these two terms instead of one from each side. So if it if it helps, draw a dotted line where that equal sign is. So that gives you like whatever I do to this side of the dotted line, I got to do to this side of the dotted line. If it helps, you don't have to. I realize, at this point you're probably masters at solving equations. Okay, so here I have to isolate the variable term first, right? Because I got two terms separated by a plus sign. So I'm going to subtract the 7 first. Now, there's all kinds of ways you can do these. This is the way I do them personally. I bring down the 4x, and I get 27 minus 7 is 20. I have multiplication. That 4 is a coefficient, right? 4 times x. So to undo multiplication, I'm going to divide. Good, good. And I finally get my variable by itself, and 20 divided by 4 is 5. There we go. Number 2, I've got that 5 halves x minus 1. Again, I'm going to go ahead and put that dotted line on there because I don't want to get confused. And I have 5 halves x minus 1, so I want to get the variable term by itself first. I want to undo the minus 1, so I'm going to add 1 to both sides. And I got 5 halves x equals 20. Now, I could multiply both sides by 2, then divide by 5, but the easiest way to get rid of a fractional coefficient, easiest way,
multiply 5 and 2.
yeah, multiply it by the reciprocal. Because all of this cancels to 1, and I get my x. Now, if you're rusty at fractions or you're not really good at them, certainly understandable because we teach you fractions and then we put a calculator in your hand and say solve from that point on. I'm okay with you using a calculator, using multiplying fractions or adding fractions. It's actually really much better with a calculator. But if you want to do it manually, 20 over 1, 5 goes in the 24. 4 times 2 is 8. If you don't believe me, use your calculators. Remember, you have to sanitize your hands if you're going to use a school calculator. Right, right, right. But when you're doing multiplications and fractions, I highly suggest always putting your fractions in parentheses, adding, multiplying, dividing, and subtracting because of that PEMDAS rule that your calculators stick to. If you happen Wait a minute. There should be 2/5, shouldn't it? Okay. If you happen to get a decimal, always, you can change it back to a fraction, math, enter in. Questions with fractions. I think I went through everything about fractions. Okay, solving variables with variables on both sides, which means I'm going to have to get the variable on one side, then I solve for the variable by itself. Again, there are several different ways of doing these. Personally, I like moving my constants over first, my numbers, um, but we'll do the variables because most students do variables. I'm going to subtract 3a because I like to have my variable positive. So I always subtract the smaller from the larger. That way it keeps my term positive. So I'm going to subtract 3a from both sides. Be careful. Make sure you're keeping like terms lined up. Bring down your constant, 13. 9a minus 3a. Don't forget to bring down this constant. Okay. Then I'm going to add 8 to both sides. Again, be careful. Keep things lined up, right? So I get 21 equals 6a. Undo the multiplication between the 6 and the a. Divide both sides by the coefficient 6. Now, I told you guys to leave everything in fractional form, right? In Algebra 2, unless I say so, or unless the directions, I shouldn't say I say so, the directions say so. And a lot of the exceptions are going to be with your trig. They're going to want the 4-digit decimal. But you do have to simplify fractions. Now, if you, again, rusty with fractions, use your handy dandy calculators. I'm going to put in my 21/6. Now, I'm not going to use parentheses, but you could because we're just simplifying here. 21 divided by 6. I get my decimal. Then I'm going to change to math. Enter, enter, and it simplifies the fraction for me. Again, use your calculators at this point in your mathematical lives because you don't want to go back and start redoing fractions. So I have 7 halves is my answer. Right? Any questions? Are we good? You guys are fractional experts now, right? All right. Number 4 makes it a little bit more longer because now we have 2 distributions we have to do, distributive properties, because we have that number in front of parentheses. We have to distribute it over the parentheses. Be careful on this one. The minus 7x is outside the parentheses. 4 times 3x, 12x. 4 times a positive 1 is a positive 4. You want, put that dotted line in there to keep things organized. 10 times x, 10x. 10 times 4 is 40. Do not distribute it. This is not part of that quantity inside the parentheses. So just bring that down, the minus 7x. Okay, now you can go a couple of different ways here. You can combine these like terms before you start bringing over the variable term. Um, I a lot of this times I do this step in my head, but I'm going to write it all out just for teaching purposes. If you can do this in your head, feel free. 12x plus 4 equals 10x minus 7x is 3x plus 40. All I did was combine my like terms on the same side of the equal sign. Now I'm going to bring over my variable to one side of the equation. I'm going to subtract the smaller x term from both sides. Now, all that does is keep my x term positive. 9x, bring down the 4, plus 4 equals, these cancel to 0, bring down my 40. Get my numbers on the other side. So I'm going to subtract 4 from both sides. I get my 9x equals 36. Undo the multiplication of the coefficient. So I'm going to divide by 9. And I get x equal 4. Questions? Okay. All right, number 5. Number 5, 6, and 7. Um, guys, remember these?
Don't you do the cross?
Yep. I think there's even still teachers in middle school that say the butterfly thing drives me bananas. This is actually called cross products. Okay, so we're gonna when we have a ratio equal a ratio, it makes a proportion, right? And all that means is a fraction equal a fraction. Okay? So we're gonna do that cross multiplication, cross multiply. Okay. I'm going to put my x's on one side. So I have 7 times x, or 7x, equal 10 times 3. Now you can write it out. And when we get into more complicated problems, we probably would write it out. So 7x equals 30. And then solve for x, right? Divide both sides by. And I get x equal 37s. Now, if you don't know if this is reduced, again, put it in your calculator. 30 divided by 7. There's my decimal. Hit math, enter, enter, and it's 37. So it's reduced. It's in its simplest form. Okay. Here we got a fraction equal a fraction. We happen to have two terms in the denominator. So the best thing to do here is whenever you see more than one term in either the numerator or denominator, put parentheses around there. Helps you avoid mistakes. Then cross multiply. So this time I'm going to write it out. So I got my 6 times the quantity x plus 2 is going to equal 4 times the quantity x minus 3. Now I've got a couple of distributive problems I got to do. 6 times x, 6x. 6 times positive 2, positive 12. 4 times x, 4x, and 4 times minus 3 is minus 12. Going to get my x's on one side, numbers on the other. I think I'm going to subtract the 4x. And again, only to keep my x term positive, right? So I have 2x plus 12. These cancel the 0. Be careful here. I have to bring down the minus 12, right? Going to subtract 12 from both sides. These cancel the 0.
24. -24.
Negative 24. Good. Yeah, again, a common mistake here would be put 0 here. Okay. Minus 12 minus 12 is minus 24. And then divide both sides by the coefficient 2, right? So my x, negative 12. Good. Okay, number 7. Look at that. They even put asterisks there, so we know we have issues. We don't have a fraction equal a fraction, do we? We have 2 terms here. So we don't have just a fraction. We need just a fraction. So I'm going to go ahead and make this. Now, 13 and 4 are fractions, by the way. They're over 1, right? So we do have, if we could just get rid of this term, we'll have a fraction equal a fraction.
I'm confused on number 6 because if there's 2 -12s, wouldn't it be a positive 24?
No.
No,
No, it's subtracting.
it's a negative 24 and a 2. And then divide.
Yeah, that's a great question because again, it's those little detailed rules that we're foggy on because we just don't use them. Minus 12 minus 12.
It's because when you do the adding and then you do another negative sign, you do like the T sign.
Yeah, if we were to,
further down instead of putting it back on the positive side, because -12 is already on the negative side.
yes.
So that subtracting would bring it further back.
Another way of thinking about this is you're taking negative 12 and you're adding another negative 12. Okay.
And I'm pretty sure if you divide a negative and a negative, it turns
Then it would be
positive.
positive.
Yeah.
Yeah. Negative 12 divided by negative 12 would be a positive. So, yeah, it's those little detailed rules that we get rusty, especially over the summer.
Trust me, I got screwed up on a test over that.
Okay, so I'm going to subtract 4 from both sides first. So that I get a fraction equal a fraction. And again, there are other ways of solving these, but these are the easiest. So I get my negative 2. Oh, I made a mistake. I should have put parentheses around these right away. Negative 2x plus 10 divided by negative 5 equals 13 minus 4 is 9. Now, if you want to make that a fraction, go ahead. So your cross multiplication looks normal. So cross multiply. I get 1 times the quantity. Well, it's just going to be that quantity, right? 1 times that is just going to be this. Now, I could put the parentheses around there, but it's not going to make a difference because it's the number 1. Equals 9 times negative 5.
Negative 45.
Good. Subtract 10 from both sides. So they're going to try to trick you again here, right? So I got my negative 2x equals negative
55.
55. Good.
I get it now.
Yeah, but now they're going to trick you. It's still going to trick you because when we go to divide, we have to divide by negative 2, right? So now we should rewrite that as x equal 55 halves.
Do we have to put two negative signs? Or?
No. In fact, we should make it positive because it's more proper.
That's what
If you leave it as negative 55 divided by negative 2, it certainly is not going to be marked wrong. And I know this is simplified because that's an odd number being divided by an even. So chances are 2 is not going to go into them. All right. Now the fun stuff starts to begin. The really, really fun stuff. Um, Lowest common multiples. Okay, this goes back to in Algebra 2, we use different terminology. Again, we use lowest common multiples in Algebra 2. And you're probably used to hearing lowest common denominators, right? Back in grade school, you're actually looking for the lowest common multiple. If we're looking at the numbers 4 and 5, what we're looking for, that lowest common multiple, is a number that both 4 and 5 divide into evenly.
One. Or, no.
20, right? You're always going to get a multiple, a common multiple, if you multiply these together. Okay. The hard part is trying to find the lowest common multiple.
Does
Right.
one even count as lowest common?
What's that?
Does one even count as like?
It does, but it's not going to help
Go
us if,
into it.
yeah, it's not going to help us when we use 1. So in this case, 20 does happen to be the lowest common multiple, right? If you didn't know that, one of the ways that Algebra 1 probably, maybe some teachers teach it, is you take 4 times 1 is 4, 4 times 2 is, or I'm sorry, 4 times 4 is 16, 4 times, no, that's squared, sorry. Let's use 8, go back to my 8, 12, 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24. And then you use the 5. Well, 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20. God, I can't write today. 20. 5 times 5 is 25. Notice that these are the common multiples of both, and it happens to be the lowest one. That's the way they kind of should have taught you in Algebra 1. A lot of Algebra 1 teachers skip it. Now, 2, 3, and 4. Well, if we were to do this, we would have to do, 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6, and then 3. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, then do the 4. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. There's my lowest common multiple, right? So you could always do it that way. Make sense?
Yep.
Can I go to that one?
but you're going to miss the funnest part,
No, no.
right? Subtracting and adding fractions. Okay. Again, there are several ways of doing these. Personally, I always look for shortcuts because I don't like to work hard. But I'm not going to tell you my shortcut. I'm going to make you do it the long way. All right. So I have denominators here. I'm going to put this over 1 to make it a fraction. My denominators here, 1, 6, and 12. So I need to find the lowest common multiple of the numbers 1, 6, and 12. Anybody know what the lowest common multiple is off the top of their head? 12, right? Because 6 times 2 is 12, 12 times 1 is 12, so our lowest common multiple is 12. Well, here's what I'm going to do. Now, there's a couple of different ways you can symbolize this. I'm going to multiply this entire equation by 12, but what I'm really going to do is distribute that 12 to each one of these, right? Let me get a pencil. So what I'm really doing here is I'm going to multiply this entire equation by 12. But since this is outside the parentheses, right? So I'm going to multiply each one of these terms by 12. Instead of doing this every time, normally I'll just stick a 12 here, a 12 here, and a 12 here. And that's the way that I do it because it's kind of a shortcut for me. So I'm going to take this, and it's actually 12 over 1, right? So I'm going to take 12 over 1 times x over 1. There's nothing to cancel out, so I get 12x. Bring down the minus sign. Now here I have 12 over 1, 12 over 1 times 5 over 6. Now 6 is going to cancel into 12. So 6 goes into 6 once, 6 goes into 12 twice, 2 times 5, 10. Okay. 1 times 1 is 1. I'm not going to put it over 1. Here I have 12 over 1 times 1, 12. Well, anything times its reciprocal is 1. In other words, 12s are going to cancel to 1. 1 times 1 over 1 times 1 is 1. Now,
Couldn't you I don't know how to explain it. Couldn't you multiply just 5 and 1 and then divide by 6 and 12?
yes,
Okay.
yes. Like I said, there's a lot of different ways to do this. I would do it a completely different way, but
Okay,
you can do it that way too.
I think I like that better.
Yeah. If it works for you, by all means, do it. What he said was, well, can't I take 12 times 5 first, get 60, then divide it by 6 to get the 10? By all means, if it works for you, go ahead. When I was taught how to multiply fractions, they canceled out first. That's just the way they taught us. Okay, now I solve for x. I'm going to add 10 to both sides. So I get 12x equals 11. And then divide by the coefficient 12. So x equals 11/12.
Sorry, that just caught my eye and I was like, I think
Yeah. And I should teach it that way because I think you guys, that's how you guys are taught in elementary school, is to multiply first, then simplify. We were always taught to simplify first, then multiply.
Yeah,
But it's the same, you get the same answer.
it's the same thing.
I'm just so used to doing it because I've done literally millions of problems that way.
I'm glad you don't care though, because there's some other teachers
No,
like,
don't care at all.
Yeah, there's just some other teacher just being like, "Hey, you're not doing it my way." So
My
you get a
way, yeah,
0.
yeah. In fact, I've learned some ways from students that make more sense to me when I was taught. So, no, I'm all for it.
That's cool.
All right, so again, here we go. We have to find the lowest common multiple for 4, 1, 2, and 5. And we kind of did this already, didn't we? 4 and 5. It's 20, so it has to be at least 20, right? 20 is a multiple of 2, so 20 is our number. Going to multiply each one of these terms by 20 because of that whole distribution thing, right? I'm going to put 20 over here, 20 here. Now, this is again the way that I do it. Now we can do it. Let's try doing it the other way. 20 times 3 is 60. 60 divided by 4. Let's see, 15, right? Don't forget our x. Did you see how I did that? 20 times negative 2 is negative 40 divided by 1 is negative 40. 20 times 5 is 100 divided by 2 is 50. Don't forget the x. 20 times positive 1 is 20 divided by 5 is positive 4. Is that easier for you guys? Yeah. Then solve for x. Let's see, I'm going to minus 15x just to keep my x term positive. Bring down that minus 40. $50x minus 15x, 35x. Bring down the 4. Going to subtract 4 from both sides. So I get a negative 44 equals 35x. Divide by that coefficient, 35, and I get a really messy number here. Negative 44/35 equals my x. And I'm running the numbers through my head, that's reduced. And of course, the never ending word problems, right? Real estate broker's license base salary is 18 grand. She earns 4% commission on total sales. How much must she sell to earn $55,000 total? Okay. So again, the total, I'm going to do this with the verbal model just like we did, last week. So I'm going to say that the total cost is going to equal her base salary, not cost, but her total earn, is her base salary plus a percent times percent commission times total sales. I'm gonna define my variables. Let's see, the total earnings, that's given. The base salary is given. The percent commission is given, but the total sales is not. So this is gonna be my variable, and I don't know, I'll use S. Okay. Total earnings is given 55,000. Equals the base salary 18,000 plus percent commission 4%. I'm going to put it as a decimal times the total sales S. So they want to know how much this S is. So we got to solve for S. So just like we just did, I'm going to subtract, I got to get S by itself. So I'm going to subtract 18,000 from both sides. So I get 37,000 equals, these cancel, 0.04 S. Divide both sides by 0.04. $37,000 divided by 0.04. So she has to sell $925,000 of sales. Okay. To make 55 grand. Questions, comments, concerns?